Hello and welcome! Today we're going to unravel the story of a 200-year-old invention that did something incredible. It completely changed the world of textiles, sure, but it also, and you might find this surprising, planted the seeds for the very computer or phone you're watching this on right now. We are talking about the amazing Jacquard machine. So, just take a look at this. This is not a painting, it's not a print, it's woven fabric. Every single curve, every color, all the tiny details, they're all created by interlacing threads. The big question is, how on earth does a machine know how to do that? How can it possibly manage thousands of individual threads to create one single beautiful image? Well, that's the mystery we're going to solve today. So, here's what we're going to cover. First, we'll look at the problem weavers were facing, the limits of a basic loom. Then, we'll get into Jacquard's brilliant solution with punch cards. After that, we'll dive into the nuts and bolts of how it actually works, trace its journey into the digital age, and finally, check out what a modern Jacquard system is capable of. All right, to really appreciate a stroke of genius, you first have to understand the problem it solved. See, before Jacquard came along, weavers faced this huge dilemma whenever they wanted to create anything even remotely complex. So let's do a quick refresher. Weaving at its core is pretty simple, right? You've got one set of threads stretched out tight, that's the warp, and then you have another set that goes over and under them, that's the weft. That simple over and under action is what makes cloth. Now, the secret to making a pattern lies in this one crucial moment called shedding. This is when you lift some of those warp threads up while leaving others down. That creates a gap or a shed for the weft thread to pass through. Which threads you lift on each pass is what makes the pattern. Now, on a simple loom, you do this with a few foot pedals, which is fine for simple stripes or plaids, but it's absolutely terrible for trying to create a picture. And this picture just illustrates the challenge perfectly. On the left, you've got your standard hand loom. It works, but it's limited. On the right, well, that's where weavers wanted to be. But to make that incredible floral pattern, you'd need to control thousands of threads individually, and you just don't have enough feet to operate that many pedals. Weavers had basically hit a wall. And then, in 1804, a French weaver named Joseph-Marie Jacquard comes up with this incredible solution. He builds a device that you could just fit onto an existing loom to completely automate the pattern making. This was a revolution, not just for fabric, but for the very idea of how machines could think. And this is the key. You have to understand, Jacquard's invention was basically the first ever programming system. For the very first time, a machine could follow a long, complex set of instructions, not from a human pushing buttons in real time, but from a program that was stored ahead of time. You know, the easiest way to wrap your head around it is to think of a music box or one of those old-timey player pianos. The song is stored as a series of holes on a paper roll. The machine reads the holes and plays the right notes. Jacquard's system did the exact same thing, but instead of making music, the output was a woven pattern. Simple, right? Okay, so how does it actually work? I mean, how does a piece of cardboard with some holes in it tell thousands of threads what to do? The mechanics are just absolutely ingenious. So let's pop the hood and decode this machine. This here is a diagram of the Jacquard head. Think of it as the brain of the whole operation. You can see a few key parts. There's this rotating cylinder that holds the punch cards, a set of horizontal needles that are about to press against the card, and then these vertical hooks, which are the things that actually lift the threads. And here, this is where the magic happens. It all comes down to a super simple binary logic. It's just a yes or no system. If a needle lines up with a hole in the card, it just passes right through, and its hook stays in place, ready to be lifted. But if there's no hole, the card pushes the needle back, which shoves its hook out of the way. It's either on or off, up or down. It's a 1 or a 0. Sound familiar? So let's walk through one single cycle. First, the cylinder presses one card, which represents one single line of the pattern, against all the needles. The needles that find a hole stay put, the others get pushed back. Then this thing called a griff, which is basically a set of rising bars, moves up. It only catches the hooks that stayed engaged. Those hooks pull up their warp threads, creating this incredibly complex shed. The shuttle zips through with the weft thread, the griff lowers, and the cylinder turns to the very next card. And this just repeats over and over, line by line, building up this amazing pattern. So this punch card system was the gold standard for over 150 years. But physically creating all those cards was a huge, huge job. The real game changer happened when this mechanical concept finally made the digital leap, bridging that gap from physical cards to modern computers. Now this is where it gets wild. This table shows you the time it took to prep a design using the old manual system versus a modern computer-aided design or CAD system. Just look at this. Drawing the weaves went from several days down to just a few minutes. Punching the cards, another job that took days, now takes minutes to create as a digital file. We're not talking about a small improvement here. This is an exponential leap in efficiency. And this digital revolution, of course, allowed the mechanical side of the Jacquard to evolve to a scale its inventor could never have dreamed of. We're talking weaving machines of unbelievable size and precision. So get this. A single, modern electronic Jacquard machine can be equipped with up to 38,000 harness cords. What does that mean? It means it can individually control 38,000 separate warp threads all at once. That is like having 38,000 pixels of data for every single line of woven fabric. And this slide really gives you a sense of what that number looks like. It's just a dense forest of threads, a physical manifestation of massive, massive data processing. Every single one of those cords is a direct descendant of those first hooks controlled by punch cards, all working together to create woven art on an absolutely epic scale. So, in the end, the Jacquard loom was so much more than just a machine for making fancy tablecloths. It was a machine that taught us how to translate a complex, physical idea into a simple, storable digital format. It really proves that a world-changing idea can come from the most unexpected places. It kind of makes you wonder, doesn't it? What ordinary object that we use every day is just waiting for its own Jacquard moment?